more minutes and then we'll get started. Meanwhile, anyone attending today as a first class?
Yeah, this is my first session.
Sure. I'll explain about the course by end of today's class. This is a second class on Snowflake, which we are giving demo. So I'll just have a quick recap on the first class. Then at the end of the today's class, I'll explain what are the course structure and what all things. And if you have any doubts, you can ask at the end of the class.
Sure.
Fine. Let me share my screen. Okay. Let's have a quick recap what we did in last class. So first and foremost, we understood why we required cloud technologies to work with data. Can anyone give one or two points why cloud is more widely used now? That we discussed in last class? Why cloud is most preferable now, apart from our traditional systems? What are the disadvantage we had here? Can you hear me?
Maintenance.
Okay. IT infrastructure, maintenance. Then initial cost setup, that is CapEx.
Yeah.
Then scalability issue. I cannot quickly scale. These all are main issues which we have, main issues which we had. So we move to cloud, and the cloud is what with respect to AWS, it can be with respect to Azure, that is Microsoft, or it can be with respect to Google, that is GCP, which will mostly take care of all our backend things. We'll be only concentrating on our business. Okay. And then we saw some of the things called as some of the tools, widely used tools like Snowflake, features of Snowflake. And Snowflake is a software as a service where it is giving all the features that is required for you to work. You no need to go and think anything about the backend, how it's working, all maintenance thing, all. You don't need to worry. They will come up with a new features. If you want, you can go and implement that into your project. We saw features of Snowflake. What are different features of Snowflake? Why Snowflake is widely used in nowadays in most of the projects, and it has something called as data warehouse plus lake house, or it can act as data warehouse plus data lake, that is lake house. Now, what is the difference between data warehouse, lake house, or data lake? What's the main difference? What's the difference between this? Forward.
Data warehouse is the storage in the cloud. It stores huge volume of data.
Okay.
I mean, it can be it can store any type of data. It may be structured or semi-structured.
Okay. Is it correct? Data warehouse definition?
Only structured data.
Okay. We are only working with something called a structured data with respect to data warehouse. Then what about your data lake?
Unstructured, structured, and semi-structured data.
Okay, all kind of data. Then what do you mean by lakehouse? If you're keeping everything in lakehouse, data lake, then why we require lakehouse?
Both availability of data warehouse and data lake.
Okay. The main difference between your lakehouse and data lake is inside your data lake, you can go and keep any kind of data, but there is something called as governance and security we cannot do on individual files or individual data. Plus, you cannot go and change the data directly into your data lake. You need something called the lakehouse architecture, which we couple our data warehouse compatibility with respect to data lake, and we came up with a lakehouse. And we have few of the open table formats that will work well with your data lake to come up with that. Some of the open table formats are delta tables, and we have hoodie, and we have iceberg. Now, these are the open table formats where you can directly go and work with on top of your data lake. Your data lake example is something called as S3, ADLS, and Google Cloud Storage, where we are going and keeping our raw data, and on top of that data, we can go and work. We saw this particular architecture, and then we moved on to something called as Medallion architecture. What is this? What is this?
It contains all kind of layer like bronze, silver, and gold.
Okay.
Um,
We have bronze, silver, gold. Okay. Then
in the bronze layer, we stores the raw data,
okay.
whatever we have received from the source,
Hmm.
and the silver we do the
Hmm.
transformations.
Hmm. Okay. Where we are doing transformations. Okay. That is your null check. We can have duplicate checks. We can have any extra columns. Anything that is related to with your individual columns or tables we are doing. Okay. Then what about gold?
Gold is the final consumption layer, uh,
Okay. Hmm.
where we store our all required transform data.
Okay. Then what's the difference between silver and gold?
In gold, we have the apply the business logic, some aggregations,
Okay.
joinings.
All aggregation joins. Now you might have here 100 tables. You make 100 tables here. Now out of 100 tables, I record only 20 tables which are doing joins and all. I can make use of this particular Medallion architecture. And where we'll go and implement this?
Snowflake.
Okay. It can be Snowflake, it can be your Databricks, it can be your AWS Redshift, it can be Fabric. You take any of the application. Usually nowadays, most of the cloud data engineering projects follow this. I'm saying most of the thing. I'm not saying all projects follow this. It depends on business to business, client to client, what they want to make use of. But most of the projects follow this, and they bring all the data from different sources to something called as data lake, and it is called as lakehouse. Landing. Under landing, they will come all this data. It might be your DB data from it coming from on-prem data. It can be from Salesforce, the SAP. It can be coming from n number of sources. We extract using some of the extraction tools. I'll bring that to my data lake. Once my data is in my landing, here we might be having CSV data, JSON data, Parquet data, any kind of data might be there. Now I'll convert that into a tabular format here, into one single tabular format, whichever required based on that. From there, I'll start going and working on my particular requirement. Now we have a data scientist, we have a data analyst. They want to go and access the bronze layer, they can go and do. They want to access silver layer, they can easily go and do. If they want to go and use something called gold layer, they can go and use that particular layer based on the business requirement. Whatever the layer they want, they can go and make use of it. So far, we have seen this much things. Now we'll be continuing on top of that, and we'll try to understand more on top of our Snowflake. Now, I asked you guys to create a account. Did you create account?
Sagar, I have one doubt.
Hmm. Yeah.
That in the Medallion architectures, all the layers will be different schemas, right?
It depends again. If you want to create as a database or don't want one database, I want to create schema, create schema. It depends on project to project.
Okay, while moving the data from bronze to silver and silver to gold,
Hmm.
it will be, I mean, how to move it may be
We'll do transformation inside Snowflake. We'll write something called SCD logic, or we'll write something called store procedures. These are all code you'll write inside Snowflake. It will move.
Okay.
Okay.
Okay, got it.
Okay. Now, before entering into some of the things with respect to Snowflake, we'll understand first Snowflake architecture, how Snowflake is working, and then we'll come back to Snowflake and we'll get started on the hands-on. Now, before getting started into Snowflake architecture, you need to understand something called as shared disk architecture. Now, if you come and see here, you can see there is one of the disk. Okay. You can see one of the disk there is, it can be a storage, a part of storage we have, and we have different clusters. Now, what do you understand by the word cluster? What do you mean by cluster? Anyone?
It's a group of machines.
Yep. A group of machines are called as a cluster. Now we have machine 1, we have machine 2, we have machine 3. And if you consider your laptop, you have something called as a memory, RAM, and you have something called a CPU, which actually is responsible for running any of the applications in your laptop. And memory is where it is optimized whenever it will go and run any particular application, it needs to optimize at that point of a time to store something in their memory and then reuse that particular application. We have memory. In the same way, inside shared disk architecture, we have one particular storage. Now, this storage you can consider as a hard disk, which you have inside your laptop or any computers. Now you have different machines connected to that one particular storage. Now, what happens is, now this is one centralized storage that is accessed by different machines. Now, this kind of a setup usually we see in something called the on-prem system or OLAP system, where we can go and parallelly process on our data using different machines. We can easily go and access and hit this particular machine can hit the storage, this machine can hit the storage, this machine can reach the storage, and there is a consistency of data that is across different machines, that is shared across these different machines. Now, what happens is, now we have all these particular machines and all, that is consistency, everything is there. And there is something called the fault tolerance also. What do you mean by fault tolerance is, now if this particular machine is going and accessing any data at that particular point of time, if this machine goes down, we have something called as a manager inside our particular shared disk architecture that will come into the picture and make sure that machine 2 does the same work whatever is the machine 1 was doing, so that your parallel processing or whatever the things you are going and processing the data, it remains intact. But one of the main problem is, now you're going and reading from machine 1, you're going and reading some data from your disk. From machine 2, if any another user is coming and write the data, then we have something called as deadlock. Now, what do you mean by this deadlock is, inside your on-prem systems and all, you might be seeing if anyone try to go and read and another person is trying to come and write the same thing, there will be one process, one particular transaction first completes, then it moves on to the next transaction. Due to this, there is something called as a slow write and reading process. Now, what happens if multiple loads are trying to write simultaneously on one particular table, on one particular storage, it can read in the delay of process, or due to this locking issue might happen. So you need to go and coordinate with respect to this. You need to maintain that. You need to write a piece of code so that it makes sure that my particular process is working fine. Another issue is, now these particular machines and disk are tightly coupled. That means if you're increasing number of machines, you need to increase the number of storage also. If you're increasing storage, you need to increase the number of machines also. You cannot go and keep use of one particular disk only to make use of multiple machines, because there will be always something called as a disk bottleneck, because it cannot go and process that particular machine. Due to this, there is always hard to scale my particular process. That's the reason your on-prem systems, where we usually don't bring huge amount of data. We usually move from our OLTP system to some of the data to OLAP system. We try to make use of this particular architectures where only 3 months of data, past 6 months of data, we are trying to process that particular data. So we are having some of the disadvantage here. So that's the reason another particular architecture called shared nothing architecture came into the picture. Now, if you come and see this particular shared nothing architecture, what is happening? We have different machines. We have machine one, we have machine two, we have machine three. Now, this particular machines, what we are having, we have disk one, we have disk two, we have disk three. Now we have three different disks. Now here we are going and distributing our data across different disks, and it is maintained by network. We have something called as one particular network that is maintaining each and every features. We have different independent nodes which has their own CPU, memory, RAM, or anything with storage. If anything parallel processing need to happen, it will happen with respect to that. Easy to scale, because if you want to go and increase, I can add one machine and one more storage here. It is much more easy to scale, and there is nothing with respect to bottleneck because there is no shared disk architecture is not there. Here you're not making use of one particular architecture. But the problem is, if this, what happens is, let's say we have 100K records. Now, due to this is a distributed system, it might go and distribute data like this: 30K, 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 or 40K, whatever the remaining data is, it is distributed like this. And we need to make sure that whatever the distribution is happening, it is in a good way. If you are not doing proper distribution, there might be a situation that your performance will decrease drastically. And whatever happens, now I'm going and reading some particular query and I'm trying to read first 50K records. Now we have 30K records here, 20K records here. Now it needs to coordinate on top of your network, and it needs to bring that particular data, and it needs to shuffle that data. Due to this, what happens? There is a data movement across different disks, and there is always something shuffling of data might happen. Due to this shuffling, there will be decrease in performance. And if you have anything with respect to complex data is coming, there might be chances of uneven data distribution. For example, if I have 100K records, there might be a chance there. Here only 60K records. Here it can come next 25K records, and here it might come 5K records. If this uneven distribution of data happens, now what happens? My performance will decrease drastically because it has to move across the network again and again. We need to make sure that whenever I write a piece of code, I need to make sure that all the data is distributed across this disk perfectly. And what happens with respect to date joins? Now, suppose we have a very one small table that is having around 20 records, and I am having that particular records here, that is table one, and I need to go and join table two that is distributed across three different storage. That time it needs to go and bring from this data, this, and it needs to go like this. So what happens? Performance decreases. So we use something called as a broadcasting. Broadcasting is nothing but on the go, you go and keep that particular data on all the disk if that particular data size of data is very small. So at that time, data duplication might also happen. And all these things, what more complexity or so much headache you have to take care, because if you don't design this particular data architecture properly, your performance will hamper every time. So this kind of architecture usually follows by your Amazon Redshift or any of the Teradata or any of the with respect to Apache Spark. Now, I will not say exactly like this with respect to Spark. It is some of the distributed system what we see. On top of this, we have a lot of more features inside our Spark, but most of the things you have Apache Spark or Databricks follow these kind of architecture. But due to we are having a lot of issues on both of the architecture, there comes your Snowflake. Now, what does Snowflake do? Now we need to overcome this particular combination. It has overcome this all both issues. It has come up with one of the smart way of combination where it has taken some of the features from your shared disk, and it has taken some of the feature from your shared nothing architecture, and it combines and solves the problem. Now, how does it looks? Now your architecture looks like this. It has three different layers. Now, under this particular three different layers, it is going and managing all that particular data. We have something called as a metadata service layer or cloud service layer. This cloud service layer makes sure that each and everything. Now, whatever infrastructure I want in the backend, what is the best optimization plan I require to make sure all this distribution is happening across all the particular storage. I will take care of that. It will come up with its own particular optimization plan, and I require power to do all these things. Those whatever the CPU cores, powers that you require to work on top of your disk or storage, that is taken care by your virtual cloud layer or something called the virtual warehouse layer that will take care of everything. Now, inside your Snowflake, it is decoupled architecture. Now, what do you understand by decouple? What do you understand by the word decouple? What do you mean by couple?
It's a pair.
Okay. Opposite to couple is what?
Single.
Okay. Same way, here your virtual machine and disk are not tightly coupled to each other. Now, if you want to go and increase your storage, you go and increase. If I need to increase my virtual warehouse, you go and increase. It will not be tightly coupled. So all these things, whatever the virtual warehouse need to go and work on top of that storage is taken care by your something called as a cloud service layer. So all the issues with respect to your storage, where if in respect to your shared disk what happened, it is tightly coupled, you can't go and increase individually, that has been removed, and each node was having its own particular disk. Now it is uneven distribution was happening, you need to go and maintain all these things. Now your Snowflake will do what? It will completely remove that, because it has something called as a cloud service layer. Inside that, it is coming up with an optimization plan, it is managing all the infrastructure. Now you need a compute where I need to go and work, and if you had in the shared disk architecture, I need multiple compute, I'm going and attaching to my shared disk, and I cannot go and increase. Whereas independent computes are there, but you need to go and maintain that scalability is issue. Whereas all that particular things have been taken care by something called a virtual warehouse, that you can individually increase the size of one virtual warehouse, or I want to increase multiple virtual warehouse, I can go and add that also. Now, whatever the concurrency is there, as I said, inside your shared disk, if anything is going and writing on the same disk, it is going and doing what? Locking system. Here also it happens, some scaling issues will happen with respect to shared nothing. Whereas inside your Snowflake, inside our storage, what we have something called as a micro partition. Now, what are this micro partition and all? We have dedicated class for that. But on the high level, now whenever you go and write anything on top of your storage, it will create a chunk of 50 to 500 MB of micro partitions, and all this particular micro partition, whatever the metadata related information, what is the minimum, what is the maximum record in this, how many count is there, each and everything is managed by your metadata layer inside your cloud service layer. So it is keeping a track of all this particular something called a micro partition, and these micro partitions are immutable. What do you understand by immutable?
We cannot change anything in the particular memory location.
So since this particular micro partition immutable, if you're going and making now you're going and adding another data, it will go and create a new micro partition. So using this particular all memory statics and all, it is making sure that you have high concurrency and you're doing parallel processing, and multiple people can come and work on top of your something called a storage or make use of your virtual mirrors. Now maintenance and all, you no need to worry again. It is fully managed by your cloud service layer, which is having security features and all, and performance is always high because it has highly performed micro partition. And on top of that also, you can go and write code. Now if you can write more optimized code, much more particularly optimize your Snowflake architecture will be. So this is how on the high level it looks like. We have three different layers inside our Snowflake. One is cloud service layer, second is virtual warehouse layer, and the last is centralized storage layer. Now, under this particular centralized storage, now we have seen inside our last class, your storage can be your S3, ADLS, or Google Cloud Storage. Now, on what it will depends, where we are using S3, where we are using ADLS, and where we are using Google Cloud Storage.
In the cloud level.
Yeah, but how you can say that I'm using S3 in the backend it is using AWS or it is going Google?
While we selecting a cloud, then automatically it will take it.
Yeah. Did you guys create an account?
Yes.
Now, while creating an account, it is asking you three different cloud, which cloud you need to go and say. If I use something called the AWS, in the backend, it is making use of all S3 features, that is data lake of with respect to ADLS, S3 features of with respect to AWS, and then it is going and creating all that in the backend. Now, what happens is this particular whatever the things are stored inside your storage, it is highly compressed and columnar storage. Now we have highly compressed and columnar first, and let's understand what is highly compressed. Now you have 1 GB of data. If you go and do zip of that particular data, how much it will go and reduce? Around 250 MB. It can go. Depends on the whatever the files you have.
Yes.
Now, keeping 1 GB of data is much useful, or keeping 250 MB of data is much useful?
250 MB.
Now you're decreasing your storage and all. So we have 250 MB of data we are going on. Now automatically you with the help of your cloud service layer, your Snowflake does that. Now whatever you are going and storing, even though you have added 1 GB of data from your external storage into your table, but it will always go and compress state data and make use that your storage is much more lesser inside your Snowflake. Now if I have a zip file, can I directly go and write anything on top of that particular files? Can you
No.
operate directly? Now again, I need to do what? Unzipping.
Yes.
So your cloud service layer take care of that. Whenever you are going and doing reading that particular data, it will unzip and whatever the data is there, it will display. So each and everything cloud service layer take care, but store data is stored inside your S3. Now any kind of data you come and keep, it will increase based on whatever the data is there. And Snowflake will charge you based on the GBs of data or TBs of data that you have stored on top of your cloud. Now, once you have that particular data here, now it is something called as a columnar storage. Now, what do you mean by this columnar storage? Now, I have a table. Now, I have a table. Let's consider this table. I have ID, I have name, I have age. Okay, I have 1, 2, 3, X, Y, Z, 20, 30, 40. Now, inside your OLAP systems or OLTP system, we use something called as a row level storage. Now, how does your row level storage works? Now, this is your first row. It will take that first row and it will keep the first row 1x20. It is your second row. It keeps the second row. It will keep 2y30. Next row, it will keep 3z40. Next row, it will keep 4a50. Now we have like this particular data. Now, if you're coming and inserting data, updating data, it is much more easy because it will directly come and work on top of that row. But if I'm going and doing aggregations of age, let me say average of ages in my tables, I'm going and doing what it has to do. It has to go and access these many particular storage. Yes.
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 So aggregation joins and all, it becomes much more complex inside your row level transformation. So optimization decrease drastically. Now what happens to overcome this? Now what we'll do in something called as columnar storages. Let me use columnar level storage. Columnar. Now inside your columnar, I have ID. All IDs will come like this. I have name. All name will come like this. I have age. All age will come like this. So it is keeping your column level storage. So whatever the data is there, it is going and keeping. If one more column is required, it will again go and add. If next number of columns are there, it will come and add like this. Now in this way, if I go and do aggregation, it will only go and pick this particular age column. Now your performance will be drastically increased inside your OLAP system because this particularly it is storing in a columnar storage. This is what in the backend your Snowflake is going and keeping. Any doubt in this?
So at this time, in case we need to retrieve anything, then also it will take some time, right? Like,
No, here retrieve and all, it is much more easy, right? If you're taking column ID, age, and if you're only selecting these two, it can go and bring here. But here, what it has to do again, three different rows it has to go and hit. So fast retrieval is less inside OLAP system, where OL OLAP system fast retrieval is more. OLTP system it is less. But what happens here? Read is more, but write whenever you command write at that time it is needs to go and create one more columnar storage like this. Whereas that performance might decrease here, but not as much as with respect to OLTP system because we have a lot of more optimization inside OLAP system. It will take care. But why we mainly use OLAP system? For aggregation, reading data. It's not like always you are writing data into your tables. Mainly for analysis purpose we use, right? So at that time, columnar level is much more useful. Got it? Yes?
yes.
Right. Let me quickly remove this. Sorry for that. Okay. Now that all things is taken care by your cloud service layer that is keeping with respect to storage system that is taken care by your storage layer. It is keeping all that particular data and all. Now what happens with your cloud service layer? Inside cloud service layer, I said something called the infrastructure management. Whatever the things is there with respect to infrastructure that the account level roles, whatever the things are there, all the things with respect to your organization level. Now you are logging into your particular Snowflake account. Now this particular infrastructure only should go and do something called as authentication and authorization. What do you mean by a difference between this authentication and authorization? What's the difference? Anyone?
Authentication means just he will try to join at the time it will do that authentication, and then
Mm,
if he need to modify anything
mm,
into
mm.
particular things, then it will authorize the.
Okay. Now I have joined a new company. Okay. You this is your first day and you go and say you don't have any IDs or anything. You just go. What will security will say? You don't have access
Yes.
because you don't have any authentication here. They have not given you any particular to go enter into this particular building. They have not given any IDs for you. Whereas now they give authentication. They say, okay, you belong to this particular company. We can come and join this company. You show that particular slip. I got the offer letter. He'll give you temporary access and you can go until you get that particular IDs and all. But as soon as you come, we have seen in our last class something called the server rooms. Now, do everyone have server room access?
No.
So who have that authority to go and enter that particular server room, only those can do. In your whole building, a part of my particular, whatever the part is there, only for that particular part, I don't have authority, whereas I can go and access the whole building. The same difference between that, if you have authentication, then only you can go and log in into your Snowflake account. And if you have authority, then only you can go and access certain objects inside your snowflakes. All those things, how to go and check this particular access control, authentication, infrastructure in the backend, what all things is happening in the backend, each and everything your cloud service layer take care. Now there is something called the optimizer. Now you write a particular code. Now your cloud service layer make sure that I'll come up with a best plan so that if anything is stored in my cache, now I have stored in every particular cloud service layer, virtual warehouse layer, there will be something called a cache where it will temporarily store your particular past query, whatever the data is there. Now it will come up with the best optimization plan so that your virtual warehouse don't go and consume lot and lot of credits. So everything is taken care by again your cloud service layer. Now we have something called a metadata management. What do you understand by the word metadata?
So information of data.
Yeah, any information from a table, objects, store procedure, functions, anything you go and create inside your Snowflake, all that metadata information is there. Now under your something called storage, I said micro partitions are created. These micro partition metadata information is also been here. Now using this particular metadata management, it will come up with a mesh optimization plan and any security thing with respect to creating a user, accessing the particular thing, virtual machines, whatever the object to give that particular access, each and everything is taken care by. Once you write a code, your cloud service layer makes sure that I have this all things been working properly. Now, since it is working there, now we require power to work. Now, when I go and use something called the AWS to go and create my account, S3 is what it is giving for my storage, where I require power to go and execute inside your my Snowflake. Your again AWS will give virtual machines in the backend. It will go and create a virtual machines which required power to go and work on top of your data. Now, how much these particular virtual machines are required? If I require 10 number of machine, if I require one virtual machine with highest configurations and all, that all things we can come and do inside our Snowflake. And based on whatever the virtual machines you use, that virtual machines only will go and work on top of your data. Now you have 1 TB of data and I'm using only small virtual machine which is having 2 GB of RAM and very small core processor. It will obviously take more time to go and work on top of that data. If you increase the something called as a configuration of your laptop, how smoothly it will work in the same based on that, we can go and control anything with respect to virtual machines. Now, all together, it will work and make sure that whatever the data you are working on top of that, it works perfectly fine and I am be able to go and access. So in the backend, how it will go and work is first and foremost, we have something called as a cloud service layer, which is also called as a brain of your Snowflake because it is the one who is responsible for doing each and everything with respect to how your particular query needs to work. This particular brain of your Snowflake, it will go and access all your metadata. If you will see whether you are going and exiting, please continue. If you're going and executing any piece of code, let's say I'll say select star from my table. I'm going and doing this particular query. It makes sure that you have particular authentication or authorization on top of this particular table or not. Once that is there, it will go and parse that particular query. It sees whether the query, whatever you have written, is correct or not. Once that particular query is correct, then it will come up with an optimization plan using all the metadata informations that are having with respect to your micro partition. Once that particular optimization plan is done, then it will go and submit that particular query to go and see whether I need to go and display this particular data to end user or not. Once that is also gone and executed, then it comes and what does it create all the particular metadata lookup everything. It comes up with a perfect plan, but it has just come up with a plan. It is not responsible for bringing the data or executing the data. Then comes your middle layer called as a virtual warehouse layer. Now again, don't get confused with respect to data warehouse and virtual warehouse. Okay, virtual warehouse is a machine that you are using. Data warehouse is all together whatever the system is there, that is a data warehouse. Now this particular virtual warehouse, now based on whatever the query you have given, based on that it will, and whatever the warehouse computations you are done. If you are given what are the configurations you are defined on top of your virtual warehouse, it will take that particular data. It will go and communicate with respect to your storage layer. Now, once it communicates with respect to storage layer, now all the data will be in columnar, compressed, and encrypted format. Now that particular data will become decryption, whatever the things are there. Now, based on the whatever the power it is doing, it will work in the on top of your Snowflake. It will bring that particular data independently and then it will communicate back to your cloud service layer, because cloud service layer is the one which will go and display the data. Now once it communicates back to cloud service layer and once the data is able to display, now virtual machine layer says my query completion is completed. You can go and cache a particular data into my virtual warehouse, or you can cache inside your particular RAM also that you're having with respect to your cloud service layer. Now, next time if I run the same query, it makes sure that if any data that is there in cache, I'll come and read that particular data. In this way, your something called the Snowflake architecture is working. Any doubt in this? Are we good here?
Sagar,
Hmm.
uh, for the storage layer, Snowflake stores in the I mean different cloud storage or using its own storage.
No, it has its now, as I said, right? When you went and created a Snowflake account, you use AWS, right?
Okay.
It will only make use of AWS services. It will never go and use Azure service or GCP. Now, on top of which cloud you have created account, only those services are made use in the backend. That
Okay.
services you don't have access. You cannot directly go and see that particular S3 bucket and all. You don't have that access. Everything Snowflake will take care. You can only see that data using queries or SQL queries inside your Snowflake.
No, I mean the Snowflake doesn't store its data. I mean
No, it doesn't store. It
it
that
rely
part.
on an external cloud, right?
Always Snowflake don't have its own power. It doesn't have. It depends on the cloud. Now, whatever the cloud you are using, that cloud it only creates a services in the backend. Okay, it will manage that particular service. Each and everything Snowflake will take care. They will not give that particular access to you. But if you need to go and store, you went and created a Snowflake account on top of the AWS. It will always make use of S3 in the backend to store all the data.
Okay, okay, got it. Yeah, thanks.
Sagar,
Hmm.
this virtual warehouse, so whenever I require, I can scale in and scale out, or
Yeah.
it can be controlled by the cloud.
No, we can do that. We have a dedicated class for that. Don't worry. One complete class we'll see where we'll scale the data. Virtual warehouse will decrease. We'll see different. We'll add different virtual warehouse. Everything will.
Yeah. Okay. Thank you.
Okay. Any other doubts? Okay. Can anyone explain now how the three layers are working briefly? What are three different layers in Snowflake? Now, why I explained to shade disk and shade nothing is it's a very important question. They'll ask what is shade disk architecture, what is shade nothing architecture. Now, how Snowflake is making sure that this particular disadvantage is taken care and how it's working. Can anyone quickly explain architecture of Snowflake? Briefly, I'm not asking more in detail, just briefly. Why? You guys do not understand?
Yes, Sagar, we understand. I mean, it has three layers:
Hmm.
cloud services layer, compute layer, and storage layer.
Hmm.
In the cloud services layer, it's acting as the brain of the Snowflakes.
Hmm.
It manages all kind of metadata management,
Hmm.
authentication, and authorizations for access related thing, uh,
Hmm.
uh, query parsing,
Yep. Hmm.
and optimization things.
Hmm.
Coming to the compute layer is the middle layer where it has the virtual warehouses.
Hmm. Yeah.
Uh, yeah, I mean, warehouse scanning and processing the data happens here in the micro partitions.
Hmm.
All kind of joins and aggregations we do here in the micro
Hmm.
partitions.
Okay.
And then next is storage layer. It is the centralized storage.
Hmm.
Mm, I mean, all the Snowflake storage is depends upon the cloud we will choose. Like it
Hmm.
may be AWS, GCP, or Azure.
Hmm. Okay. Good. So in this way, these particular three layers are going and working. Now, Fine, Sagar. I got to know how our particular Snowflake architecture is working.
Sagar,
Sagar, a question.
sorry to interrupt you. I have
Yeah.
one small question. Can you move to the previous page?
Hmm.
So, Sagar, here the after the compute layer, it is when the data has been stored in the storage layer, right? So after the storage level only, after completion of storage, then it is going to give the message to the cloud service layer to the query, right?
Yeah.
Otherwise, it is directly went after before from the storage level to it is not going to give the signal to the cloud service. It is given by computer layer only, right?
No, whatever the data is coming, right? Now you have, let's say, 10 GB of data. Now I need to display this data. I need power. To display any data, you need power, right?
Yes.
So it will go and communicate with virtual warehouse saying that take a power of virtual warehouse and display this. Now, once that data is displayed, we have cache inside our warehouse. Now it will go and keep that particular cache information. That is there. It will then this will go and intimate your cloud service layer. Okay, data is displayed. Cache, my storing some data in cache. If you want, you can store your data inside your cache here also. So two types of caches are there. It will store here and then it will display. Always these two will communicate. And whatever the storage is there, right? Inside the storage, to come up with plan, these two will communicate.
Okay, sir.
All right.
Yeah. Thank you, sir.
The
Okay.
follow-up question for the same Sagar.
Hmm.
So now the cache will be part of storage layer, or
No, cache is a part of your virtual warehouse and cloud service. There will be no cache here.
but how the then what is the role of storage layer? That will be that whatever the 10 GB of data
Permanent
what you have
storage.
mentioned.
It's a permanent storage. This is a
Okay.
temporary storage inside cache.
Okay, that
What?
10 GB will be loaded in this storage layer, right?
Which one? Sorry.
The 10 GB, whatever take an example, the 10 GB data will be stored in this permanent layer,
No,
and that will
always.
be
Yep. Always in the storage layer. Your permanent state.
okay.
Okay. It's kind of a disk. It's kind of a RAM. If you compare in your laptop.
Oh, okay. That
Okay.
okay, got it.
Fine. Now, when I ask you guys to go and create a account, did you see these different editions?
Yes, sir.
Okay, which edition you created?
Enterprise.
Now, based on your use cases, whenever you go and create any account, Snowflake has given different editions. Now, one is something called a standard edition. It's a very mid-sized business who is just getting started with something called Snowflake. He need to explore what all things are there with respect to Snowflake. Whereas very limited features are there, they will go and make use of this particular standard edition. Most of the companies will not use this because it's just an introduction features and will not be able to go and work most on. We cannot do a lot of POCs on top of your standard edition. Most of the companies, that is around 90% of the companies, will go and use something called the enterprise edition. Inside your enterprise edition, all the feature, almost all the advanced feature, anything whatever you want to do, something called the time travel, data retention, any of the features you want to do, each and everything you can have that particular features inside enterprise edition, and a particular business can run a company effectively using something called the enterprise edition. Now we have something called the business critical also. Now on top of this particular enterprise edition, you need most of the edition with respect to which is very business critical. You need to make sure that a lot of compliance I need to pass. I need to have more of the data encryption, decryption, whatever you are having in the backend. It is of more secure way. Now your financial related particular things are and all that will come under business critical editions. Now, as you go increase your editions, the price of each and every particular, whatever you are using, virtual warehouse, whatever you are keeping storage, it will also go and increase based on that. Now, finally, we have something called the virtual warehouse. Now, if you come and see, I shown you in your last class, there are something server rooms. Under that, there is something racks are there, and whatever you go and create in the backend, Snowflake is making use of this particular rack. Now, if you have a particular apartment, under that you are going and renting different rooms. For that particular rent, you are going and applying. You are paying particular rent. Whereas I don't want to have, I have very, very important particular, my client is very important. It's a very business critical. I don't want anyone to other than me. For example, this might be company one. This might be other company might be using the cloud. I want one particular home or one particular building, everything for me only. Then I'll go ahead use something called the virtual private cloud, where each and everything is given to you, everything is managed to you, but again the cost is more. This for this you need to go and connect to Snowflake, then only they will be able to go and provide this particular access. Now we'll be going and working mainly on the enterprise edition, because each and everything is there inside this feature. Now I don't have anything with respect to compliance and all, business requirement and all, encryption part and all. I don't want that headache, so I'll be not using anything with respect to business critical edition. Now, it again depends on project to project inside your real time. If your project is mainly with respect to finance related, it will be always business critical, whatever the Snowflake account, or else your normal e-commerce projects are there, any of the healthcare projects, a simple project that doesn't require most of the compliance, business critical, they always try to make use of enterprise edition. Now, once we go and create our account, now how your Snowflake will look like. This is a very high level. I'm showing again, we'll go each and every particular objects. We'll go and see inside our Snowflake. But once you go and do, this is an organization you are going and creating. Now under organization, now whatever the account you have created, that particular account is created. Now we are going and creating free account. So directly access will be with respect to free account. Whereas for organization, they will be given particularly organization. Under that particular organization, I can go and create n number of accounts. Now I have this particular account. Now under that particular account, I can go and create n number of warehouse, n number of database, n number of different users, roles, whatever the objects are there, I can go and create. But whatever the data you are working with respect to data, whatever you're working, each and everything is under database. Now we have database. Under that we have schemas. Under that schemas we have table, view, stage, store, procedure, whatever the objects. There are a lot of objects that comes under your Snowflake. Each and every particular objects will come under with respect to whatever the data is there, that will come under databases, and we'll be going and learning one by one each and every object. Now, while working with any of the data, we need to understand something called the roles. Now we have one dedicated class for this particular role, no need to worry. But what happens is whenever we are going and working anything with respect to Snowflake, we need to, one particular role will be assigned to us based on our whatever. Now, for example, you have a data engineer. You are only having access to go and read with respect to one database only. You no need to work with another database. I need to create a particular user for you. First, as I create a user, you will be able to log in into my Snowflake account. Now I need to go and assign a role where I need to make sure that these are the limitations I can go and give. Those limitations, I'll create my own particular roles and then I assign. No, these are already there inside my Snowflake. For practice purpose, we can go and make use of this. Now I will be using most of the things with respect to account admin, because I'll be showing different features. Each and every particular privileges with respect to your account will be there with respect to account admin. There is something called security admin, where you can go and manage, role, grant access. These are all things you can do. Now, we no need to worry as a data engineer for now. Most of the things, we have one particular class for role-based access control, where we need to go and do something called the row level security, the column level security. At that time, again, I'll come and I'll show this. This is mostly admin kind of activity, but as soon as I log in, I'll be making use of something called the account admin. Any doubts so far? If you have any doubts, please let me know, or else we'll directly get into practicals. Are we good?
Yes, we are good.
Just a minute. I don't want to again waste time, so I'll bring few scripts and we'll create tables.
So the last three roles are applicable mostly to the database level, right? The first two are on the overall Snowflake level.
Yep. You can say like that. Okay, I have this particular scripts. We'll use this. I'll add this. Don't worry. Okay. Now I went to my Snowflake. Now I'm going. I gave my user and password. I logged in. Which layer will come into the picture? Inside a Snowflake architecture, which layer will take care of this?
Cloud service.
If you have authentication, then only you will be able to go and log in into your Snowflake account. So your cloud service layer is coming and taking care. Now, as soon as you log in, you click on, there is something called down here. There is your name and whatever the account you're using is there. You go and say settings, come to settings, come to general. There is something called set warehouse as a SQL editor for this particular account. You first, for now, you go and disable this. Okay. For now, you disable this. I'll explain this, what all this, all things and all in further classes. For now, you go and disable. Now, when I come and click here, you need to go and enable that, not disable.
Yes, I got one question. So once the account is created, so we cannot go back and change the cloud service layer, right?
What do you mean by that? Password you're saying?
No. So while I'm creating the Snowflake account, in that I'll be selecting the cloud layer. Where it is.
You can, once account is created, if you are selected AWS, now
Cannot
again,
go back and change
in
Azure.
real time, if you want to change, you have to go and connect with Snowflake. You need to take help of that. Then we can move all those things we can do. But now you cannot do. For free trial, you can do. Okay, fine. For now, you enable this. I don't want you guys to use it because you need now they have come up with something called a workspace where you can go and work with respect to Snowflake and all. But since we will be showing some experience in Snowflake, now just 1 or 2 months before they have come with that, we will be working in a old way how that things are working in our real-time organization and all. You should need to have that particular idea. So first go and enable this particular thing. And if you come and create the, why it is still saying SQL file. Should say workspace. Let me come refresh this. Let me sign out and sign in. Did they remove permanently now? Okay. Enable this. General. Sheets will be open in all the users tooling in the global. Yeah. It's not working for this. Okay. Fine. What I do is then, okay, fine. It is not showing for my particular account, but let me see. Should not come. Yeah, use that. Should have come. It's not working. Some issue with Snowflake. Fine. We'll see that. For now, I'll use SQL file only. We went to particular SQL file. Now, as soon as I come with respect to SQL file, let it load. Else, let me use. Let me see if any particular. Okay. Now we can come and write our code here. Whatever the things are there, I'll be able to come and write my code. Now, any SQL file, .SQL file, I want to come and edit. I'll say database creation. I'll give my name as a database creation. Now we are having this. Now, if you come and see here, whatever the code you execute, that particular code is here, but virtual machine. If you see, there is something called as a virtual machine here. Can you see this? Can you see this icon? As one. Now, whatever the virtual machines you are using, that particular virtual machine is here. I don't want to use this because I need to show you few things. My particular account is not showing that. Let me try one more time. Now it's coming. Okay. We'll use workspace. Fine. It's better. Okay. Now I don't have any databases. I don't have anything. We have virtual machine here. Now, if you come and click, what are all the size? Now I have different sizes of virtual machines. Based on the sizes of particular virtual machines, I'll be having particular power. Now, what is this multi-cluster? What is max and all? I'll be showing you that. There is something called the auto suspended NAN. Okay. Let me come and first edit this. Monitor query services transformation. Compute. Under manage, we have compute. Let me first edit this because I need to show you. 10 minutes it is there. Suspend your implementation showing. This my Snowflake account is working something strange today. Running 1, 2. Okay. Let me come back. Auto suspended. It is not coming. Better I'll create one virtual machine for you. Let's say Snowflake virtual machine warehouse. I created one virtual warehouse. I'm using extra small. 1 crate per hour it will take. We have some additional things. I'll come make use of this and I'll create that. Now I have created my own virtual warehouse. I'll be going and making use of this particular warehouse. Now we'll have dedicated class. Now what is this extra small and all? We'll see in further classes. No need to worry. Now I'll come and make use of my particular warehouse. And if you see, are you able to see here 300 seconds?
Yes.
Now what do you understand by the word auto suspended?
I mean, the particular warehouse is not in use, so it will automatically stop.
Yeah. Now for 300 seconds, you are not executing anything. You are now whatever the thing Snowflake is charging inside your Snowflake is based on the virtual warehouse. How much you use that particular virtual warehouse. Now, if you come and see, there was something called a extra small and all. Now, based on the virtual warehouse, whatever you use, they are going and using something called as a credit. Now, if you see, there is 388 credits left inside your Snowflake free trial. Now, this particular credit is converted into whatever the currency based on wherever your Snowflake account is there. Based on that, they will go and charge on that. We'll see that in further classes, how these all charges and all. But now we may need to make sure that whatever the things we are using, again, why it is showing NAN? Something strange today. Snowflake is acting. Fine. Now we have this particular account and all. Now we are having it is a started conditions. I'll go and suspend now. For now, I have suspended. Now, if you come and suspend, can you see a gray mark? Can you see gray?
Yes.
Yes.
Okay. Now, the same thing if I come and something strange. It's not working properly today, my account. Why it is doing that way? I need to create another account better. Having some issues with this, with respect to this Snowflake account. See. I'll resume for now. Okay. As soon as I resume, okay. All right. It's not working. I need to create another account. Now, as soon as I resume, you're able to see green mark.
Yes.
Okay. Now, whenever your particular account is there, it will come and work like that. Again, it's not showing, not started. So I'll do one thing. I'll create today one more new account, and tomorrow when we come back, I'll show. There is some issue with this respect to the Snowflake account. It is since it's a free trial, right? We'll be having these particular issues and all. Every time it will. Usually it won't happen, but for this particular account, it is showing like that. I'll create a completely new account when we come back tomorrow, and I'll show how this all things are working. But for now, on the high level, now whatever the things are there, if I need to go and write my SQL code, I'll write under SQL warehouse. If I need to go and write my Python code, I'll write under Python warehouse. There is something called as a notebook. Now, what is notebook? What
Like
is
a
notebook?
Jupyter notebook where we
Yeah.
can compile each one.
So if I come and create any particular Jupyter notebook, now whatever your Snowpark code, okay, now what things we are writing with respect to Snowpark code, the same thing I can come. Now inside my particular Snowflake, I can write as a Python code or I can write as a SQL code. Whatever the things are there, I can come and do. Now we have something called the ingestion. To add ingestion, I can use something directly from my table. I can browse from my local and I can add. There's a one way of doing. No, I don't want to do that. I want to load from my AWS S3. I need to go and connect to my AWS S3. I can do Microsoft, I can do Google, I can do. There are a few things I can come and make use of my particular add data for ingestion. Now, migration and all, they have given this all new things now. It's not yet completely used. Whereas transformation, we have something called as a DBT projects. Now, if you come and see, I said, right, now they have integrated your full DBT inside your Snowflake. We can go and create our DBT projects here also. Now I need to go and orchestrate my different objects. I can use my task inside my Snowflake. Now we have something called as dynamic tables. This is a different way of writing particular making use of table, which automatically refreshes that data. We'll see that in further classes. This is also kind of transformations I can do. That I can come and do. Now we have anything with respect to AI ML. Now all things have been supported. Now you can go and create your LLM models. We can create any Streamlight applications. Everything we can come and make use of this particular AI ML applications inside our Snowflake. Each and everything that will take care. Now whatever the things. Now whenever I go and write any particular code, it will go and create one of the queries in the backend. It will go and create each and every IDs. I can track my whatever the things I'm doing inside my Snowflake using this particular query history. Now services, job, traces and all, we'll see in the further classes, but monitoring with respect to your code and all, I can come and do this. Now, whatever the things with respect to your data, that will be under catalog. And we have created different databases that will be under this particular catalog. And I can go and access. For example, I have created this particular database. Under that, I have particular schema. I can go and see my schema. And we have different things, whatever the things are there, each and everything I can come and make use of my particular catalog. Now, any governance, user, anything with respect to my Snowflake related account, I can do. Data sharing is where I can share my data from one particular Snowflake account to another Snowflake account, or else I can share that to market for other people, and I can charge on top of my data saying that if you make use of my data, you guys need to subscribe this data. You can pay for this particular data. I can do those things with respect to data sharing. And compute is where you are going and creating your warehouse or pool of warehouses where I can come and make use of this particular warehouses and all. And admin is where you're going and checking your bill, accounts, admin, all the things are whatever the things with respect to admin types, it will be there. And how much credits are there, how many number of dates will be showing here. Now upgrade is nothing but if you want to go and upgrade, and now this particular credits are over, you need to go and add credit and all. Please don't do that. As soon as these credits are coming to end, if you have any code or anything, please save there and then only, because once this particular credits are over, we cannot go and access that particular Snowflake account. Using the same email ID and all, you can create one more Snowflake account as a free trial, but all the things will not come. Again, from start, we have to do. So from now onwards, whatever the code, whatever the things we write, keep it as something with respect to SQL file or any text file and keep it in with respect to yourself. So if you want to come and practice, you have that code again and you can practice next time. Now we have something called as Snowflake. With respect to Snowflake, if you want to appearance and all, if anyone wants to go and work with dark theme and all, they can come and convert into dark theme based on their use cases and all. We can make use of that. Now we'll be coming one by one now for the classes. Okay, this is a high level on top of your Snowflake. I'll fix this particular issue. I'll create a new Snowflake account. Once we come back tomorrow, we'll see directly with respect to, we'll start something called as a time travel. The very first topic with respect to Snowflake, we'll see how time travel is working. If you guys have any doubts, please let me know.
So this credit will be shown during other level also, like enterprise level, or it won't be there?
No, for enterprise level, they have given 400 credits. Whatever you use, they will give 400 credits for 120 days using the link which I shared, right? For that.
No, I'm not talking about like our 120 days system. I'm talking in the regular days when you are working in the Snowflake. Does it always show this much
It
credit?
won't show. For you, there will be no credits for you because it's a free edition, right? That's
Yeah.
why it's when you upgrade that, it for hazard data engineering, you will not be having access for this. This is admin level. High level architects will be using that. You'll be not able to see this.
Okay.
Okay.
Yeah.
Sagar, to create the account, you have shared the link.
Yeah. It is in free class. Okay, I'll add for your particular things also. Okay, right, better. I'll add here also. Okay. Meanwhile, any other doubts with respect to course and all, let me know. I'll add that link. Create a Snowflake account. Let me add here. Added. If anyone, they can go and access our free course access. Under that particular link is there. You can always come and click this and you can go and access. Okay. Any doubts?
No.
Okay. Others who is attending as a today's first class? Any doubts with respect to course? Duration?
Sagar, can you explain like what are the topics we will cover in this course and duration?
Sure. I'll show the curriculum. Now, under your particular, whenever you go and access our KSR Data Vision account, just create your particular account if you don't have account. Under that, explore free courses. Under that, Snowflake with AWS is a free course. You have 5 free courses. Under that, we have something called a curriculum and roadmap. We can always go and see this, each and everything, whatever the topics we are seeing, that particular topics have been explained here. For content, this is a content what we are going and learning. Now, first and foremost, we have completed so far SQL and Python. It has been completed. We are getting started with Snowflake. Now, those who want to attend any SQL classes, they can, on 8 a.m. onwards, we are ongoing SQL batch is going. You can join that. Or for Python on the evening, 8 p.m., Python batch is going. You can go and join that particular Python batch. You can go and talk to Mesh. You'll give access. Or else you can go to recorded. Or else any other particular classes based on your requirement. If you want, we can always go and access that particular record, that particular access will be given. Or when I'll come and next time when I come and start my SQL batch or Python batch, you can come and attend there also. Now, based on your whatever the feasibility, you can go and select based on that. But now we are getting started with something called a Snowflake and DBT. Now, for next 8 to 10 weeks, we'll be completely diving into Snowflake, where we'll be learning 10 to 15 use cases in Snowflake, 10 plus use cases in DBT. Each and everything will be doing practical. There will be nothing with respect to theory. Now, since it is a start of the Snowflake class, you need to understand Snowflake architecture and all. I was doing a bit of theory, but most of the things, 80% of the time, it will be practical. And on top of each and every topics, there will be assignments and all that will be given. After we finish our Snowflake, we'll be doing one end-to-end project on Snowflake. That is some completely dynamic related projects where we'll be doing a lot complex things. We will go for 8 to 10 hours. We'll be building a framework. Each and everything will be in dynamic where you can go that and show directly into your resume. After that, 2 to 3 weeks will go for DBT, and that will be having one end-to-end project in DBT, which will go for 3 hours. Now, after this only, you guys can get started for interviews and all. We can get and started here. Now, after doing that, either we'll be starting with Snowflake or Snowpark, which will go for 2 to 3 weeks, where we'll learn each and everything with respect to PySpark in Databricks and Snowpark in Snowflake, and we'll build one end-to-end project here, which will again go for 3 hours. And then we'll implement your Databricks with respect to ADF, Snowflake with respect to ADF, and Snowflake with respect to Airflow. We'll build few pipelines here that will go for 2 weeks. Now, at the end, we'll be seeing most important AWS services that we can come and integrate with respect to AWS. That will go for 2.5 to 3 weeks, where we'll be learning each and everything. There we'll be having one end-to-end projects. Now, this is how your roadmap will be there. For your detailed something called as each and every concept, we can come and access our particular syllabus. Each and everything, whatever assignments, whatever use cases we'll be doing, each and everything is added under this. Did I answer your question? Was that question? Sorry. Vijay Kumar.
No, sir. So it's almost completing by 5 months or 6.
Whole syllabus is for 5.5 months. Now, since SQL and Python almost we completed, so 1.5 months is completed. Now 4 more months will be there for this batch.
Okay, got it.
Yeah.
For the guys who joined now, you can consider 5.5 months only, because you need to be joined SQL and Python separately.
What is the phase
Okay, if
structure?
you are going with a fast track, maybe you can finish the classes with the records. Yes, we can finish in 4 months.
Just to know
Yeah,
fee
any
structure for this course.
fee structure will be, it's a 40,000 for one go. You can able to make it 36,000.
Okay, understood.
If it is installment, 40,000. 3 installments, you can make it
Does it include both SQL
every
and
month, every
Python?
30. Sorry?
Does it include both Python and SQL Master?
Yes, it's including. It's including. The course is a complete course is a 5.5 months. Don't confuse. It's 4 months. It's a 5.5 months only. This course. Who are joined now? For you also, it's a 5 months, 5.5 months. SQL and Python, you can join in the later classes. Means after completing the Snowflake, you can join. Or else, if you have a time, example now 8 o'clock, we are started SQL for another batch for data analytics. If you are capable, means comfortable, you can join that SQL. Or else in a 19th January, we are starting one more batch of for a data science. SQL and Python common for all courses here. So evening you can join if you have a time. So depends on your comfortables. Same Sagar also maybe will start in a Feb end or March one more at 8 o'clock. If you are comfortable, you can join SQL and Python at that time. There is no restriction. SQL and Python, you can join any courses in KSR. Wherever it's available. Okay, I hope you got it right. Any questions, team?
Got it, sir. Thank you.
By any chance, if we discontinued in the middle, is there any chance to continue in the next batch?
Yes, within 1 year, like within 8 months, not 1 year, like within 1 year, we have to finish the live classes. After 1 year, if required, we can able to extend the record sessions, but live, it's a difficult to join. Reason, the content, right? Frequently, we will try to change. Example, Metallian is not part of the previous Copilot is not part of the previous batch also, but this batch we added. And Metallian is not part of the 24 March and July batches also. Later we added. So it depends on the market requirement. We will try to add some new concepts. Sometimes we will try to remove the old concepts if not required. Example, MongoDB we used to teach in 22, 23. Now it's not required. We are not adding, but a new concepts we added. Our first batch Snowflake is hardly 2.5 months when it is started in 2019. But now it's becoming 5.5 months. At that time, only SQL, Snowflake, DBT. That's it. Now SQL, Snowflake, DBT, Metilin, AWS, ADF, Snowpark. and Snowpark versus Spice Park. So it depends on the company's requirement. We need to be added new topics. Now companies also expecting multiple concepts, particularly in US market. So this course also designed for both people, like US and Indian market. Yes, Sagar, you can join another session. I will take care here. If anyone have questions, guys, you can ask me. I will be there here. So, and the complete placement assistance will be, it's a completely our responsibility. We are not going to be do any support or help. It's a purely responsibility. Getting call onwards, scheduling an interview, we will guide you. Once you got the call, and you have to be take care properly, like attending an interview. And if it's not able to clear also, we can discuss again what kind of questions you got and why you are not able to answer. Is there any topic we missed from our side, or else you need a more assistance? So our team is continuously will supporting you, and frequently we will gather the information from you also, like any interview questions that came from the apart from our content. So those topics also we will try to make it as a interview questions explanation videos in YouTube.
Extending records are free, right?
And we
No
have a
exams.
mock interview tool also, like you can able to predict the questions, at least 40 to 50% of the questions. By example, tomorrow you have an interview with the Infosys or Wipro. If you got the JD, by using that JD, you can able to practice before actual interview. So it will give more confidence to you, and it will help you to clear the interview little easy. Imagine if you are attended 5 to 6 times for the mock interview, every time it will try to ask you different questions. So almost your practice is done. Yeah, there's something. Sorry, you are saying something, guys.
So extending video records and changing the batch are completely free, right?
Yes, it's completely free. That's what. Again, it's a time. Example, you joined this January, but after March or April, in between, you thought like you are not able to continue, and you told me in the March and April, yes, you can change the batch, not a course. Yes, the next batch, available batch, you can change. But again, you came in December 26 something. I can't change the batch, but I can extend the course access, the records access. You can get it. You no need to pay any extra penny. Got it, right? Any questions, team here? If any questions, you can ask me, like placement related, or else like a dog queries related,
So
calls
how is the
related.
job market
If
for
anyone have
Snowflake in the US?
yes, it's a very good. Like you can just open your LinkedIn and check it there, so you will get to know like how many openings is right now available. In depends on your state. So Snowflake market is so good. That's the reason we are adding multiple skills. Matillion is not mandatory in India current situation, but why we are added depends on the US market requirement.
Okay, thank you.
So that's the reason we added frequently we are adding new concepts to consider US and Canada, Canadian and European market also. So we do have a consultancies all over US, Canada and UK as well. But US and Canada little active compared to the other countries. Yeah. So hope still any questions? So you can use the same link. We can join tomorrow also. You can attend first 5 lectures. So today will be the second session. 3 more classes are there. So you guys also can check the 3 classes. If you are really comfortable with the way of explanation of the content, and then we can continue further. So meanwhile, you can do some research in outside also. But from my side, I will tell you, I am getting the frequent feedback from the students, the lengthy courses. Some people are expecting to finish in 2 months. Honestly, maybe it's not possible from our side. We have to be take the lengthy course only. Then only we can able to get in a better job and you can able to sustain in the market. Getting in a job is one side. Like after getting job, like how you are going to be sustained, because you guys are not joining as a freshers. Most of the people are entering into the Snowflake data engineering as at least 3 to 5 years of work experience. Worst to worst. So you have to be showcase that much of capability in your real time, right? So that's the reason we are taking lengthy courses and with lengthy topics. So I can assure you, like you can get a job by own. You no need to be depend on any other activities or illegal activities kind of proxies. You can able to crack interview by your own, and you no need to be depend on any other people. You can able to handle entire work by your own. This I can promise. That's the reason the course will be little lengthy. Not little. It's maybe double than the other organizations. 2 3 months course, maybe we can't promise. It should be like 5.5 months. Who knows SQL and Python? Maybe because they are skipping that. For them, it's maybe 4 months, but including SQL and Python, it's 5.5 months. Right. Hope it's clear, guys. Akbar, Amit, Chandru, Gideon, Ritvik, Tipesh,
Yes, yes.
Uday,
Thank you.
and Udit. Okay. Great, great. Okay, guys. We can meet tomorrow. Yeah.